Alright, welcome everyone to today's video. Today we are going to be diving into the new reworked Level 1 NCEA Mathematics, and we're going to be looking at the first past paper to see how difficult the questions were and which topics were actually covered. If you haven't already subscribed to the YouTube channel or my social media, make sure you do so you don't miss any future updates. Let's dive right in. Our first question is: the perimeter of a shape is the distance around the outside of the shape. The perimeter of the rectangle shown below is 56 centimeters. Form an equation and solve it for the value of x. So we want to find x. We have been given a perimeter, so we just need to form that equation. So we start with the perimeter is equal to 56, which is the information they have given us. Now we add each of the sides together, and I like putting brackets around it each time anyway, even though they have given us the brackets already. Now we need to collect like terms here, so all the x values, all the terms with an x, and all the ones without the x. And if we put them together, we end up with the perimeter being 10x minus 4. Well, we have been told that the perimeter is 56, so let's substitute that in, and then we can solve a linear equation. We want x on one side, everything else on the other, so we're going to remove the negative 4 by adding 4 on both sides. That will leave us with 60 is equal to 10x. Now we want to get rid of the 10, so we need to divide both sides by 10, leaving us with x is equal to 6. And this is the answer to the first achieved question for this paper. I think a very fair question. The second question is: in a triangle ABC, the length of side AB is y centimeters. The side AC is k centimeters longer than side AB, where k is bigger than 2. And the side BC is 4 centimeters shorter than AC. The perimeter of the triangle is 5 times the length of AB. Find the perimeter of the triangle ABC, giving your answer in terms of k. So now there's no diagram given, so every time you get a question like this, I highly recommend drawing a little diagram to help you out. Now I've put all the information that they've given us in this diagram, a triangle ABC. And it says that AB is y, that's the yellow part. It says that AC is k centimeters longer, so that is y plus k. And then we have that the side BC is 4 centimeters shorter than AC. That means I copy what I have for AC, y plus k, and subtract 4. The question also tells us that the perimeter is 5 times the length of AB. Well, the length of AB is just y. So we're going to get, and the expression for the perimeter is adding all 3 sides together. I have marked them in 3 different colors so you can see which ones I'm talking about. So adding all of those sides together should give us 5y. Now this equation we can simplify a little bit by putting all the like terms together, and we get 3y plus 2k minus 4 is 5y. Now the next step that we want to do is we want to remove the y's from one side. We want to know what y is before we can start solving for any of these. So by removing 3y on both sides, we get an equation for y in terms of k. But it would be easier here if we then divide both sides again by 2 to make it y equals. Now on the left hand side, make sure that you are dividing each term by 2, because this would be a fraction. Kind of like 2x minus 4, all in brackets, divided by 2. Now we have that y is equal to k minus 2. So since we know this, we can replace all of our values for y with k minus 2. But the question is only asking us to find the perimeter in terms of k. Well, we already know that the perimeter is 5 times the side AB, which was 5 times y. And in the top you can see I've put the value for y so you can remember. Now, if we now substitute in k minus 2 for y, then we should be able to get the answer. But be careful, every time you substitute, you should put brackets around, because it's 5 times y, so the whole thing of y. And expanding the brackets here will give us 5k minus 10, which is the final answer for the perimeter of the triangle. All right, the next question is involving a lot of measurement and 3D models, 3D shapes. So the diagram below shows a vertical line PT. And as I walk you through the question, make sure you're checking the picture to see and understand where these features are. So the points B, C, D are all joined to T. The points B, P, C, D form a rectangle. That is the bottom part, the green part, and the yellow part means that we are perpendicular. Perpendicular means we have a right angle. So, of course, there's some more side length given. Yeah, so now let's have a look at what we actually need to do. For the question, we want to actually find the distance from C to T. And in most of those 3D shapes, you should always be looking for right angle triangles that you can use Pythagoras theorem or trigonometry in. So here's one of these triangles, and I started with where my answer should be. I drew a line from C to T. That is what we actually want to calculate for this question. So now I'm going to check what the triangles are that I can form using this one line. And this pink one is the first one that comes in mind. And remember, we were told that the height going from P to T is perpendicular to the base. Another triangle that after that I can see is the bottom part. We have a rectangle in the base, so that means we have right angles in each corner. In the triangle before, I was using the diagonal of the base in my triangle, so maybe we need another triangle where we're using this triangular base, or at least the diagonal. So let's have a look. We first want to calculate PC. Now, if you remember PC, that was the diagonal on the bottom. So I have drawn here the actual right angle triangle, and we know that the bottom is 12 and the other side is 10. So how can we figure out what the diagonal here is? Well, we can use Pythagoras theorem. So a squared plus b squared is c squared. We only need to note that c has to be the longest side, so that is PC. If we substitute in our values, then we get exactly this statement here, and we can start putting our questions together. You're welcome to put this in the calculator here, but if you don't have one or you're not using one, I have just done the calculations with you. And we end up with 244 is PC squared. But we don't want the length of PC squared, we want the length itself. So we're going to take the square root here to take away the squared. Now we have a value for this diagonal. Now let's have a look at the other triangle. Remember, we have this diagonal in the bottom or in the base that is square root of 244. And if we now want to find the length from C to T, we use the first triangle that we were looking at. And in red, you can see this is the triangle that we're interested in. The hypotenuse is the value from C to T that we are interested in. We have the height being 8, and we know that from PC, that is the diagonal PC. So this is the value that we've already found. So now we can go ahead and again use Pythagoras theorem here and substitute in our values. Now here the shorter sides are going to be 8 and the diagonal PC. So let's put all the values in. We know what the numbers are. The square root of 244 squared, they kind of cancel out. So that's just going to be 244. but feel free to do this just in the calculator to get the answer that 310 is CT squared. Now again, just like before, we need to take the square root on both sides, which will leave us with the final answer that CT is the square root of 310, and you're welcome to put this in the calculator to find the exact answer. Just be sure to round correctly and to write your answer with the correct unit. The next question is about a sphere is a dimensional object shaped like a ball. The diagram shows a regular box containing 6 spheres. So the diagram shows how the 6 spheres could be packaged into a cylindrical tube that you can see on your side. The spheres fit tightly into the box, into the tube and the box, sorry. So that means that there is no room in the side. They fit exactly onto the edges. So all spheres in both the box and the tube are exactly the same size, and they're giving you the volume is 150 centimeters cubed. Show clear working to decide which container, rectangular or cylindrical, has the greater empty space. Well, empty space means the air between the spheres. By calculating the percentage of empty space inside each container. So let's have a quick brainstorm here. We want to find the percentage of the air. So that means we're interested in the air divided by the total, which is the volume of the container. And because it's a percentage, we multiply by 100%. This will be our final answer. But how do we get there? Well, we need the volume of the air in the box, and we need the volume of the box to calculate the percentage for our rectangular box. But we also need the volume for the air of the tube and the tube itself, so that we can do the same calculation for the second container. So let's do them one by one, nice and slowly. We're going to start with the volume of the sphere because that is the only thing that they have given us. The volume of the sphere, you can look this up in your formula sheet, is V is 4 over 3 pi r cubed. So the only thing that we know is that the volume is 150, so we can substitute this in. Now we have an equation with one unknown variable, which is the radius, so we can solve for this. Here we can multiply both sides by 3 to get rid of the fraction. Then we have 450 as 4 pi r cubed. Now we don't want a number in front of the r, so we're going to divide both sides by 4 pi. And now I have given you the exact number for r cubed, but you're welcome to put this in the calculator if you want to, if this makes it easier. You can also do the cube root here to find the value of r itself, the radius, which is 3.29 and some other decimals. Now I'm going to put that information right at the top so we can use that later. Let's start with the box. If we look at the box, we can see that there's 6 spheres nicely arranged in there. We need to find out what the dimensions are, and you can already see this in the picture here. We have 6 times the radius for the length, because we have 3 balls and each has 2 radius in length. Then we have 4 for the width and 2 radii for the height. So we can calculate the volume of this box with the formula length times height times width. Well, we just substitute our values in and multiply the numbers together, then we get 48 r cubed. Well, we already know what r cubed is. Remember, that's at the top. We've calculated that, so we can substitute that value in. And now simplifying this will give us 5,400 divided by pi, or you're welcome to put this in the calculator and round this. The next part that we need is the volume of the air in the box. So the volume of the box minus the volume of the 6 spheres is the volume of our air. Well, we already know the volume of each sphere was 150. So we can just substitute 6 times that amount from the volume of the box that we found before. Using the calculator, this will give us 818.87 centimeters cubed. Now the last step, we need to calculate the percentage. So we need to have the volume of the air divided by the volume of the box multiplied by 100%. Since we know all those values now, we just substitute them in and put these calculations in the calculator, and we'll find ourselves with the answer of 47.64%. Now, we've done half the question. We found our percentage for the box, but we need to do the same thing for the tube. So let's have a look at the volume of the tube first. Here we can see that it's a cylinder, so it's kind of a prism. So the volume is the cross-sectional area times the height. This is also in your formula sheet. The cross-section here is a circle, so we're going to have pi r squared multiplied by height. Well, again, we know that there are 6 balls on top of each other, so that means our height is going to be 12 times the radius. Each ball or each sphere has 2 radii, that's 1 diameter, and if we have 6 of them, we have 12 times the radius. Multiplying together, we get 12 pi r cubed. But again, we know what r cubed is, so let's replace it with our 450 over 4 pi. Well, here we can cancel out the pi's. They're divided by each other. That makes 1. We can divide 12 by 4 to give us 3. Or you can just put this whole calculation in the calculator to get your answer. But again, we need to do the same calculation to find the volume of the air. So that is again the volume of the tube minus 6 times the volume of each sphere. Putting this in the calculator will give us 450. And the same calculations as last time, we need to do the volume of the air divided by the total, which is the volume of the tube, and multiply by 100 to get it as a percentage. Substituting in our numbers will give us 33.33%. So our answer is going to be the box of 47.64% has more airspace compared to the tube, which has 33.33%. Awesome. This is probably the first E question, and it's quite long. I think everyone could be able to step by step go through them, but this would have taken a long time. Now, question 2. The diagram shows a rhombus. A rhombus is a shape with 4 equal length sides, and the length of the diagonal BD is 10 centimeters long. And they also give us that the perimeter is 60. Again, I've color-coded these in the picture, so it's easier for you to see straight away. We want to find the value of x, which is the angle at A. So let's have a look what we can do. The first thing here I see is, well, we have a rhombus, so we're probably going to have to use the features of the rhombus. I can also see that there is a right angle triangle, well, 4 of them actually, in the middle where the diagonals cross. I'm also looking for an angle, so all this together makes me think I probably have to use trigonometry here to find an angle. So let's start first with the information that we know. Each side is going to be the perimeter divided by 4. This is because all the 4 lengths are the same. Well, this gives us 60 divided by 4, so each side is going to be 15 centimeters long. We've also been given that BP, the green line, is that the green line BD is going to be 10 centimeters. Now, in order to find half of this from B to P, we're going to just divide 10 by 2, which will give us 5. Now, why would we want this? Well, as I said before, I can see a right angle triangle, and if I know all the measurements, I can use this to figure out the angle. So we've already figured out the side length 15 and 5, but be careful about the angle because the angle here is actually just half of what we're looking for, half of x. So what do we do here? We use trigonometry to figure out the angle. SOHCAHTOA, hopefully you remember all the triangles for SOHCAHTOA so you can construct them during the exam. And now, what do we have? Well, if we have a look, 15 is the hypotenuse, it's opposite the right angle, and 5 is opposite the angle, so that's the opposite side. We have the opposite and we have hypotenuse, so what does that mean? We need to use sine. So let's set up the equation. Sine of the angle is opposite over hypotenuse. Let's put in our numbers. Opposite is 5, hypotenuse 15. And now we need to remove the sine by doing the opposite. So we do the sine inverse on both sides. I guess we can simplify first. So then we get x over 2 is equal to sine inverse of 1 over 3. Remember, every time you're trying to find an angle, you need to use the inverse functions. Sine inverse, cosine inverse, and so on. Putting this in the calculator, and make sure you are in degree. If you don't know how to figure that out, make sure you check out my videos that are coming in future for calculator use. Once they're ready, I will link them in the description. Now we get that our answer still is x over 2, so we would have to multiply it by 2. And over here, I'm just doing both steps in one go. If you put this in the calculator, you get 38.94 as your answer for the degrees for our value x. So that was the second achieved question for our question 2. So let's have a look what the next question is. The diagram below shows a rectangle with a gray stripe through it. Now we can see that FB and EC are parallel lines. I've marked them for you with a little blue arrow. And we know that the angles 33%, which you can see are as in the diagram. Couple more measurements that they've given us. Make sure you take your time in an exam to really understand what all the information is that they've given you. Now we want to find the area of the stripe BCEF. Well, let's have a look. It's asking us for the area. So the first thing we need to ask ourselves is, what kind of shape do we have? We have a parallelogram. So if we wanted to find the area of such a shape, we need to have the right formula. And we know that this is base times height. But how does that help us? Well, if we know the base and the height, we're done. Well, clearly the base here has already been given. It is 2. So we just need to figure out the height. And remember, the base and the height are always on a right angle to each other. That means we are looking for the height which goes straight up all the way from the base to the top of the shape. Well, if you look at the picture, this looks like it's going to be the height of the rectangle. So from C to D. And remember, what else have we been given? Well, we've been given information with an angle and measurements. Well, again, I can see a right angle triangle here that will help us figure out this height. This is the right angle triangle. It's in the right bottom corner, and I've just copied this. And here we have a 30-degree angle. We want the height on the right-hand side, and we've been given 28 as our bottom line. Using hypotenuse, opposite, and adjacent, we can figure out that we have been given adjacent and we want the opposite. So how do we use this? We use TOA. So let's set up the equation. Tan of the angle is equal to opposite over adjacent, and substituting in our numbers. However, we don't know O. Well, that's the height that we're looking for. How do we solve this equation? Well, tan 33 is just a number. So in order to get height by itself, we have to multiply both sides by 28. So we get 28 tan 33 degrees is equal to the height. If you put this in the calculator and make sure you're in degrees, you will get 18.18 meters. Now, once we have this, we can just finish our calculation over here, put this in for our height, double it because that's what our base was, and we get a final answer for our area of the parallelogram, 36.36 meters squared. Be sure to use your units at the end, and because it's asking for an area, it is squared. The next question gives us a diagram that shows a prism with rectangular base. The cross-section is the symmetrical trapezium. Now, you can read through all the information, make sure that you understand this, pause the video if you have to. And now let's have a look. We're interested in showing that the length PF, which I marked green here, is 1.7 something K meters long. Show you're working. So this is a show question. So we already know the answer. We just need to show how we're going to get there. And again, just like with all of the 3D shapes, except of course a sphere, we are going to be looking for right angle triangles. And you can already see one that I've posted in. Well, we know here that the adjacent, hypotenuse, and opposite are set up in this way because where the angle 60 degrees is. But how do we figure out what the opposite here is, the line that we want? Well, we need to know at least one other side in this triangle. They've given us information about the trapezium in the front, so we can actually figure out what each little part on the sides is. Well, if the bottom is 4K and the top is 2K and it's symmetrical, that means there's 2K that are still missing on the top, and they're equally distributed on each side, so that each side needs to be 1K. So let's put that onto our triangle and actually calculate what we get for the opposite here. This is the triangle just a little bit bigger so we can see better. So again, we need to use SOHCAHTOA, and here we want the opposite, we have the adjacent, so we use tan. Tan of the angle is O divided by A. Substituting in our value, we got O divided by K. And again, we want to solve for the opposite, so we're going to multiply both sides by K. Now we just need to put in tan 60 degrees in our calculator, and that is actually the answer, 1.7321. K is equal to the opposite, which is the length PF. Now the answer is very easy. It's just a proof, just like that. You don't need to do anything else once you've got this last line. The next part is, given that the volume of the prism is 649 something else meters cubed, find the value of this K. Well, let's have a look. We're going to start with our volume, just like always. This is what's been given to us. Well, but the next thing we need to think of, well, what shape do we have? We have a 3D prism with a triangular cross-section. Sorry, a trapezoid cross-section. So let's put all this together, and this is actually on your formula sheet. We just need to then put on all the information that we have. And if you remember, the length all the way was 8K. So now we just need to know the area of the trapezium. Well, this is in your formula sheet. I've copy-pasted that at the top. So we just need to put in all the information. From before, we know that the top part was 2K, the bottom part was 4K, and the height is exactly what we calculated in the question before. Make sure that you understand where these numbers come from. If you have to, go back to the big picture. And now you can just substitute everything else in the calculator, or you can do the calculation by hand, and we get 41.5704 K cubed. Well, we only want K, so we're going to divide by the number in front on both sides. Just a lot of calculator work now. And how do we get K when we have K cubed? Well, we need to do the opposite of cubing, which is the cube root. Right, putting this all in the calculator will give us that K is roughly 2.5 if we round it to as much as 4 decimal places. So the answer here is K is 2.5 for those values. All right, and we're going to start with question 3 in just a moment. All right, we are back. I just had a couple of lessons with my level 3 students who have their exam tomorrow. So let's finish this question over here. So the third part of the assessment is all about your graphs. So the first question says, find the coordinate of the y-axis intercept for the exponential graph given here. Now this looks like a more complicated question, but we just need to know one thing. What is the definition for a y-axis intercept? Well, we need that x is 0. Every point on the y-axis has x is 0. So that means we need x is 0 for our equation. So we can just substitute in x is 0 into our equation. Well, this is our equation. So let's put in 0 for x. Then we get 3 times 0 plus 2 in the power. And you can just put this whole equation just like it is in the calculator, or you can follow through with the steps with me. So 3 times 0 is 0, plus 2 becomes 2. So our power is just going to be 5 to the power of 2 plus 4, which is going to be 25 plus 4 is 29. And this is already your answer. But just be careful, they're asking you for the coordinates of the y-axis intercept. So you need to make sure that you write it in coordinate form with both your x and your y value. But remember, from above, we already knew what the x value was. The second question is giving us a sequence in the table below. Find an equation that represents y for any given x value. Justify your answer by showing appropriate mathematical working. So first of all, we need to identify what kind of relationship x and y has. So we check for the first difference here. We check how much is each y value increasing for each one step in x. Well, these are not the same, so we're going to now check the second difference. What is happening with the increase each time? And we can see the increase has a steady increase of 2 more added each time. So let's have a look here. The first difference, what does that tell us? The first difference is not the same. That means we do not have a straight line. If that number was the same, then we would have a linear equation. But the second difference being the same tells us that we have a quadratic equation. So we have a squared term in our working. So what does this mean? Well, this means we already know what this function is going to look like. We just need to find the equation now. You should now just put the table as it is in the calculator and then press quadratic, because we figured out that it's quadratic. Together in combination with your working showing that it's a quadratic, this will give you full marks. However, I will still run you through the process of how to figure this out by hand. So we have our standard form for a quadratic, which is ax squared plus bx plus c. And here we need to figure out our values a, b, and c at the end. Let's start with a. So a has a formula. It's the second difference divided by 2. Well, from the question before, we saw that the second difference increased by 2 each time, so it's positive 2. If we divide it by 2, we get 1. So that is our value for a. For b, there's a different formula. The first difference, one of the first differences that we had, that was plus 11. We take that one and we subtract 3a from this. Now we know what a is, so we substitute in a is 1 and we calculate, we get 8. Now for c, there's not a way that you can calculate this with a different formula, so we need to substitute in our values a and b into our equation and then substitute in a point. So first, if I substitute in a and b, I get x squared plus 8x plus c. Now we're going to substitute in any point, and I'm just going to use the first one, which was 1 for x and 24 for y. Substituting this in gives us this equation with one unknown variable for c, and we're just going to put 1 squared plus 8 times 1 in the calculator, gives us 9, and we need to move 9 to the other side by doing minus 9. Then we get our value for c. And remember to write your final answer, your equation, y is x squared plus 8x plus 15. If the graph of y is drawn, the one that we've just had, so it will appear at the top for you. Identify all the features on the graph of y using your answer from BI. In your answer, describe at least 3 different features. Well, we need to have a look. What are features for a graph? I can think of the y-intercept, the x-intercept. That's the 2 that are general for most cases. But we have a quadratic, so we also could think about the vertex, which will tell us about how it's shifted left, right, up and down. There's one last feature for a quadratic, which is the scaling. How can we talk about the gradient? So let's talk about all 4 so you have an idea of what you can talk about. First, the y-intercept. We've already discussed this before, means x is equal to 0, so we can find the y-intercept just by substituting x is 0 in the above equation. As a bonus, if you remember, the last number in the standard form for the quadratic is already our y-intercept, so we're not surprised here to get 15. You can either substitute in 0, or you can say the number at the end is the y-intercept in standard form. The second feature here is the x-intercepts, our roots for the equation. So just like the y-intercept means x is 0, you should know that the x-intercepts mean y is 0. This is a concept I have to teach most of my students because it doesn't always seem that straightforward for my students. Make sure you write these down and note these down, because talking about any kind of intercept later on or for any future questions will immediately give you the answer on what to do next. So let's substitute in y is 0. Then we get a quadratic equals 0. And now you've got multiple options. You can just chuck these into the calculator and see what you get. And again, make sure you check out the link below once I have my calculator videos ready for you on how to do that. If you don't know how to do that at the moment, you can factorize, or you can use the quadratic formula, which is given to you in your formula sheet. Let's factorize this because it's in an easy form. There's no number in front of the x squared. So we get x plus 3 and x plus 5 in brackets. And how do we know it's 0? Well, that means each bracket could be 0. So if we have x plus 3 is 0, then we move the 3 over, then we get x is minus 3. And moving the 5 over for the other brackets will give us x2 is minus 5. Now these are two x values for the, these are the two x-intercepts, the x values for the x-intercept. Make sure that you remember y is 0 so you can write them down in coordinate form together afterwards. Let's have a look at the vertex form. Well, here you can do multiple things. If you remember, you can use the equation to complete the square to find what this function would look like in parabola form, in the vertex form. However, this is not the approach that I'm going to be using here. We're going to be using the symmetry of the quadratic in order to find the vertex. We always know that we have symmetry around the middle, so the vertex. So the roots are exactly equal distance away from the vertex at all times. So we're going to find the midpoint between our two roots. And as a reminder, our two roots were minus 3 and minus 5. Well, you might immediately see the midpoint is minus 4. Just as a reminder, just as a reminder, my midpoint is exactly halfway between, so we add them together and divide by 2. Now we have, for our midpoint, we have the x value being minus 4. So we can find the y value by substituting in the x value. Sorry, my dog has found a very interesting bird. So again, we wanted to make sure that we find the y value for the x value minus 4, and we do that by substituting them into the equation at the top. Once we have both of those, we have the point coordinates for our vertex, which will give us -4 for x and -1 for y. Now, what does this mean? Well, you could talk about this equation being shifted 4 spaces, but in which way? Left or right? Well, if our x coordinate is -4, then our shift was towards the left. And if our y value is -1, that means we were shifted down by 1. The fourth feature is that this has a scale factor of 1, so it is similar to the standard parabola, but there's nothing really exciting here, which is why I left this one as a bonus at the end. Let's have a look at a graph. If you were to sketch this, you would just need to make sure that all of those features are covered in your graph. So your y-axis intercept, which is 15, your roots, and then your vertex. And because my drawing isn't that great, I'm not the best artist, here is a graph from Desmos showing exactly those features that we've got. Right, we're almost done. There's 2 more questions. So this question here is another graph question. Use the diagram below to help you. And here we have points A and point B, and they lie on this blue line. What we want is we want to find the equation of this line. Well, how do we find the equation of a straight line? We need to know the gradient and we need to know the y-intercept. So here I've already drawn on your gradient. I've picked the 2 points A and B, and I have written down our rise and our run. Let's put that up in the corner so that we can move on and put away this big picture. Right, so we need 2 things, the gradient and we need the y-intercept. So for the gradient, we use the formula rise over run. And I always remind my students, rise means we're looking at the difference in y, so the difference in up and down. Whereas the difference in x is left and right movement. So if we look at our picture above, we can substitute in our values. Just remember that our rise here, the change in y, is a -6 because we're going down. You should always be going to the right. So if we substitute this into our equation, we still are missing b. So we need to substitute in any of the points to solve for b using algebra. So if we substitute in y for 4 and 5 becomes x, then we can simply put these in the calculator and we get a value for b. Now here, to finish our equation with b equals, we move the 15/2 to the other side by plus 15/2 and let the calculator handle the rest. Once we have a value for b, make sure to write down the answer, the full equation, using your gradient and your y-intercept that you found. Now, a second line G has the equation x minus 2y minus 9 is 0. Find the coordinates of the point where the F and G intersect each other and use either algebra or graphs to show this. Now, I will be showing you how to do this with both methods, so let's start with algebra. Our previous equation is again on the screen like we had it before. And remember, our equation is already showing us what y is. So what we're going to do is we're going to plug that whole equation in for the y for the other one. Why does this work? Well, remember, a point of intersection means that that is the point where both graphs share the same x and y coordinate because they're crossing over. So if y from our previous equation is going to be the same of the y of the equation G, the line G. So if we substitute these in, we just need to remember we have brackets. Why do we need brackets? Remember, every time you substitute, you should put brackets around. After that, you can decide if you need them or if you don't. But never forget to put brackets around, because here we're multiplying 2 by y. And y is this whole thing, the whole term of minus 3x plus 11.5. And as soon as we have brackets, we need to expand using the FOIL method, and feel free to draw these arrows, and then simplify by putting like terms together. So we're going to get the 3x and x together and the numbers together to give us 4x minus 32 is 0. And now I'm pretty sure everyone can take it home from here, moving the 32 to the other side by making it positive, and dividing both sides by 4 will give us x is 8. So what have we actually found here? We have found that for an intersecting point, our x value is 8, but we have no information yet on what is y. Every time we want to find points of intersection, we need both the x and the y coordinates. So let's find the y coordinate by using one of the equations that we've already got in terms of y. So here we have y as an equation. We substitute in our point x is 8, and we just solve that for y. Now, why did I use this equation? It doesn't matter which one you use, because again, the y value is the same at an intersecting point, but I didn't want to deal with any fractions or negative 1.5 in front of the x. So I substituted in the values into our equation g, and we're going to solve this for y. We're going to put our like terms together, divide by -2 on both sides, and we get -1 over 2 for y. So we can write the answer. The intersecting point is 8 and -0.5. Let's have a look how you could do this graphically if you prefer to do so. So here I actually want to talk about a quick trick. Remember, for a straight line, we only need 2 points. Well, why don't we make the x-intercept and the y-intercept the 2 points that we're interested in? Remember, x-intercept means y is 0, and y-intercept, the opposite, x is 0. So we can just take our equation that we have above and substitute these in. So let's start with the y-intercept. We're going to substitute in x is 0. Then we get 0 minus 2y minus 9 is 0. And we can move the 2y to the other side, making it positive. Make sure you don't forget the negative in front of the 2y here in the first step. Divide by 2, and we have our y value for our intercept. We can do the same thing for the x-intercept. We substitute in 0 for 9, and this is a much easier equation to solve. Move the 9 over, and we also get our x value. Now, once we have those, we can just mark those on our graph, 9 and 0, and 0 minus 4.5, and draw the straight line through. And we get the same answer, of course, being 8 and -0.5 as the intersection point. Just make sure, if you're using the graphical method, that you're being very precise. You have to be very clear on where your line is to be able to tell where exactly they intersect. Right, and this comes to the last question of this paper, which is another algebra question. Here we have been given 3 to the power of 2x plus 3 multiplied by 9 to the x is equal to 3 to the power of 4 minus 3y, and it wants an expression for y in terms of x. Well, the first thing you should notice here is that we have powers. X is in the power. So that's always difficult. In order to think of a question like this, we need to make sure that the bases are the same, because we can't multiply or combine them if the bases are different. So I've marked the bases for all the 3 parts, and I notice that they all are multiples of 3. So if I now replace the 9 with 3 squared, because 9 is 3 to the power of 2, then I get this equation. I haven't changed anything else, but just be careful again, we are replacing or substituting something, so immediately put down the brackets. Now we need to have a look. What can we do here? Well, the part that we have just changed now actually follows a certain rule. 3 squared to another power. What do we have if we have a power to a power? That means we multiply the exponents together. 2 times x becomes 2x. Now we need to have a look. On the left hand side, we have 3 to the power of 2x plus 3 times 3 to the power of 2x. Here we have the same base. What happens if we multiply terms that have the same base? What do we do with the power? Think about x squared times x to the power of 3. They become x to the power of 5. So we add the powers together. So let's do that here. We're adding the powers together on the left-hand side. And now we have a number as the power of 3 on the left side and the same on the other. So on both sides we have 3 to some power. So the only way that those two numbers are going to be the same is if the powers are exactly the same. So here we can drop the bases and we can only focus on the exponents. As long as they are equal to each other, everything is going to work out. Well, this is just an equation with x and y, and we want to find an expression for y in terms of x. In terms of x means we want x in our equation, but we want y equals. So we move everything that is not a y to the other side. So we can do minus 4 on the side, combining our x's together, our like terms, and then finally dividing by -3 to get us an equation for y. Here I would just recommend just writing a fraction with division by -3 in the bottom, and this will be your final answer for y, which will give you the mark. Awesome. Wonderful. Thank you very much for going through the past paper with me. Hopefully you learned something. Make sure you go back through the questions that you needed to work on and write down the notes, the rules that we used to answer these questions. If you need further help, I will be having lots of courses in the future over the summer. So go to my website, which will be linked later on, where you can go through all the videos in the courses, and make sure I see you next time. Bye bye.